Hello guys, my name is Edison. Welcome to another STM32 tutorial, and today I'll be covering RTCs, that is real-time clock. These are modules for timekeeping. They keep track of time in terms of date, month, year, time in hours, seconds and minutes, and also they have the sub-seconds. So RTCs are widely used in any machines that need to keep track of time. For example, we have laptops, they use RTCs, and mostly RTCs are provided with their own V source, that is the voltage source, and they use very little power. So today I'll be showing you how to use the internal RTC of STM32 MCUS. So before I go into that, I'll open my datasheet or my reference manual and explain a few things. So look for RTC. So the real-time clock is an independent BCD, that is binary coded decimal timer or counter, and it provides time of the day, a clock or calendar. So it has two programmable alarm interrupts and a periodic programmable wake-up flag with interrupt capability. So these RTC module have two registers containing the seconds, minutes, hours, either in 12 or 24-hour format. So it also has the day, that is the week of the day. It has the day of the month, and also keep month and year. And all these are expressed in binary coded decimal format. So it also provides the sub-second value in binary format. So it also does automatic compensation for the leap year, that is the month of February with 28 or 29 days, and also the days, the months with 30 and 31 days are performed automatically. So you can also perform a daylight saving time compensation. So it has also an additional 32-bit register which contain programmable alarm sub-seconds, second, minutes, hours, day, and dates. So I'll show you this in my demo. So maybe you can also check at few registers, and these are in page 670. So let me go to 670, and we have this first register. The first register is the RTC time register. So it is a 32-bit register. From here you can see that you have the sub-second we have the seconds in ones, in tens, then minutes in ones, and minutes in tens. So we also have in ones and hours in tens, and we also have this bit 22 for for configuring the time format. So this is in terms of 24 hours or 12-hour clock format. So since the seconds run from 0 to 59, we shall have 0 to that is register 0 to 3 to represent 9. The maximum of 9, that is from 0 to 9. Also we shall have this to represent from 1 to 5. You realize that you need only 4 registers to represent 0 to 9, because the maximum here we can have is 1, 0, 0, 1, which is 9, and the maximum here we can have is 5, 5, which is 5, which is 101 in binary format. So you place 5 here and 9 here to get the maximum, and when these registers overflow, so it increments the minute. So maybe you can look at another register, that is the date register. It is on page 671, so it's in the next page. So you find that we have also the dates in ones and dates in tens. So simply it's just like the way I've explained in the time register. So this register, the date register, shows the date, the month, the day of the week, weekday in units, and also we have the year. So having said that, I'll go to Cubemx and start a new project. So I'll select the board that I'm using. So I'll be using my favorite board, so 446RE. So start project. So the first thing that I'm going to do is clear the pinouts, and I'm going to enable the oscillator, external oscillator. And also what I'll do, I'll configure the pins for the LCD display. I'll also be using the LCD display to show the time and date. So PC3 will be D4, this one will be D5, so this will be D6, and this will be D7. So if you are not quite familiar with connecting the LCD, you can revisit my tutorial on LCD. So I have explained everything, how to connect and how to use the libraries for the LCD. So this one I'll configure it as output for the RS pin, and I use PA4 as a enable pin. So I'm using my LCD in 4-bit mode, so from D4 to D7, then I have my RS pin and enable pin. So the other thing I want to do is so I want to configure PC13 as a GPIO external interrupt. So I'm going to rename this reset alarm or disable alarm. So, and I'll also be using my GPIO pin 5, that is from port A, which is connected to the green LED on my board. So lastly, I want to come here to timers and activate the clock source and also activate the calendar. So I'll be using alarm A, internal alarm, and that's enough for configuration. And coming to our parameters, I'll use the 24-hour format. Then these are just prescalers to bring down the clock to 1 Hertz. So I'll explain to you in a bit. So the data format, I'll be using the binary data format, and then the hours, I want to set these to time that we can see that will be changing. So I'll have that as 23, and this will be 59, and I'll set this to 50 seconds. So I want to in the demonstration you'll see that this time will change when this reaches to 60, and it will start from 0. So we can also today is on a Monday, so I have that on a Monday, it's September. So maybe I'll configure the date to be a date that we'll see changing. So let's have these at date 30. So and the year will be 20. Will be 21, so that is 2021. So I'll have my alarm at 00. That is when now this goes to 00, we shall have our alarm, and the alarm date will be date 1, since now this will move from 30th September. So let's see in our calendar what we shall have. So that is on a Thursday, so we can have this as Thursday. It's okay. So if the seconds increases, so this will change it to 00, and we'll go to the next day, which will be the 1st of October 2021. So the alarm date will be 1. Then from there go to NVIC setting, and I'll enable my RTC alarm A and the alarm B interrupt. Then I want to go also to system view. Then under NVIC I want to enable the GPIO 13 interrupt, external interrupt. So and then I'll go to clock configuration. So for you to get accurate timing, you have to use this oscillator, which has that 2.76 kilohertz. So why I say this, if we go back to our pin configuration and under RTC, and then under parameter settings, you'll find that we have the pre-divider value, asynchronous pre-divider value. So if we divide the 32.768, you divide by 128. This simply means it is from 0 to 127. If you start counting from 0, you have 128. So 128 times 256. You'll find that we have a clock frequency of 1 Hertz. So then I think we are good to go. So go to project manager and give a project a name. So RTC YouTube tutorial. And I'll be using MDKM, that is Keil Vision. So I'm going to generate project. So the code is successfully generated. Then we open project. So the first thing I have to do is add the library files for the LCD to a project folder. So I'm going to paste them here and drop the H file into the include folder and the .c into the source folder. Then I go back to our project and right click on these and add existing files to the group. And I'm going to point to my project directory. Then I'll go to the core source and add the .c file for the LCD. So from there I'll open the main and include the header file for the LCD. So let's build the project. So our project has 0 errors and no warnings. So the first thing to do here is to go to the this RTC init function, and I'll copy the type def and place it in the private variables. So I'm going to remove the initializations. And then I'll come to the main function and a while loop. I'll have this function to get the time. So RTC get underscore get get time. So the first parameter this guy takes is the type def for the RTC, so HRTC, and the next is the RTC type def which we have initialized, we have declared here. So it is S time and it's a pointer, and the last parameter is the format. So it's RTC or format binary format binary. So that's the format you should be using. I'll declare some variables to hold the time, seconds, and the likes. So as int, so I'll have int second, and I'll initialize them to 0. Minute, minutes, hours. So I initialize all these guys to 0. It's a good practice to initialize your variables. And I'll also initialize day 0, month 0, and year 0. So from there you're good to go. So when I get time, so seconds will be s time dot seconds. Then we shall have our minutes will be equal to s time dot minutes. Then hours will be equal to s time dot hours. So the next thing that we are going to get is the date. So HAL RTC get date. So the first is the RTC type def, and we have s date, and the format is RTC format binary. So our day will be equal to s date dot sdate dot date, then we shall have our month will be equal to sdate dot month, and we shall also have our year equals to sdate dot sdate dot year. So from here, let's build a project to see whether we have any errors. So far so good, we have 0 errors and 0 warnings. So the other thing I want to do is declare another variable here, a buffer. So character hold or just buffer. This guy will take a maximum of 16. So, and this buffer I use it to print or to display, to hold the time and the date. So I use printf function to cast the dates into a buffer. So hold, and shall have time, so %d, that is for hours, then %d, that is for minutes, and %d, that is for seconds. So and then we shall have seconds, then minutes, then hours, and we are good to go. So then we display this in the first line, so LCD 1602. So what follows will be printed in the first line. So this is buffer, and now we print what is in the buffer. So I'm printing what is in the buffer. Then in the second line, LCD, we shall also have the sprint function, sprinter function, and there now this will have the date, and this will be the day, this will be the month, and then we have here. So then we'll have to print this in the second line. So in the second line, so we're going to do LCD print and we print what is in the buffer now, and then we want to delay this for some seconds, so HAL delay for 100 milliseconds. Then from there we clear the LCD. So another thing, remember we had an alarm. So when the time for the alarm matches the time in the time register, there is a callback function for the alarm. So I'll go to functions and look for RTC.C, and we have this alarm A event callback. So I'm going to copy this function without the weak object to the main, and this will be in user code begin for, and in here. So what I want to do is when the alarm time reaches, we shall have GPIO right pin. So we shall put on the LED connected to our board. So when the time for the alarm reaches, we shall have a green LED on, and then on top of that there's the pin that I configured for the interrupt pin. So I'll go to the STM32 F4XX interrupt.c, and that is where we shall see that we configured GPIO pin 13 as an external interrupt. So if we press this pin, if HAL GPIO read pin, that is from GPIO A, GPIO C, then pin 13, GPIO pin 13. Then what I want to do here is disable the alarm. You can disable the alarm. So also the function for disabling the alarm, you find it in the RTC.c. So we are going to deactivate the alarm. So we are going to activate the alarm, and this function takes the type def for the RTC, and then the alarm, which alarm, so it is RTC alarm underscore A. Then if the alarm happens before you even deactivate it, you can reset, or you can put off the green LED. So let's have GPIO right pin, GPIO A, GPIO pin 5, then GPIO pin reset. So we are going to bring down or put off the green LED. You can take the green LED as our buzzer here, or the speaker, so it will really be making some noise. So if you press the PC13 button, you'll find that the alarm will go off. So our code is building. So our program has 0 errors and 0 warnings. So another remaining thing is to initialize the LCD in 4-bit mode, and if you go to the STM my LCD, you'll find this function to initialize the LCD in 4-bit mode. So you can configure your pins, but I usually have these default thing that I use in every project. So I'll copy it in my main, and I use a code begin to. That's where I want to initialize the LCD. And something else, let me include some libraries, some header files here. And first one is stdio, so that we can use the printf function, this printf function. Then we have string .h, and then we have stdlib .h. So let's now build our code. So before we flash our code, let's see whether everything is alright. So we have that, we have the variables, we have the character buffer, and when you come to the main, we have initialized the LCD in 4-bit mode. Then from here you have the get time is alright, it's okay. Then we have the printf time seconds. So let's start with hours, and then minutes and seconds. So that's it. Let's now build. So this is seconds, so let's build. So let us now flash the code to our board. So from here you can see that we had set that hours to be 23, minutes to be 59, and seconds to start at 50. And also we have a month, our year to be 2021, that is the date will be 30, and we have the month of September, and it is on a Thursday. So, and we also have our alarm at 000 at date 1. So what happens is that this time will overflow and goes to 00. When this goes to 00, we move to the next day, which is 1st October, and then we shall have our alarm on. So in for the case of our alarm, the pin which is connected to our green LED is the same pin that I have connected my buzzer. So so let's see this. I'm going to manually set the board. So, and time started as we had pre-configured, and then we wait for the alarm at 00, date 1, 10th, that is 1st of September. So I also configured PC13, which is the blue button here. When you press the button, you will deactivate the alarm. So that's it. So you can also, if we reset the board and press this button, you find that you will have deactivated the alarm even before the time reaches, so there will be no sound from our buzzer. So thank you guys for following up with me. If you like the video, please like, share, and even subscribe. So if you have any question, leave it in the comment section. I'll get to you. So I hope I'll see you next time with another tutorial. Thank you.